Okay, so let's go ahead and get started. The first thing we're going to do is we're going to find the exact values of the sine, cosine, and tangent for each angle by using a sum or difference formula. In this case, right out of the gates, we're going to be using a difference on question 1, and then we're going to be using a sum for question 2. And so this is from page 400 in our textbook, and let's get organized. The sine of 315 minus 30, the cosine of 315 degrees minus 30 degrees. Let's go ahead and add on the degree symbol here. And then I'm going to kind of bring question 2 down. I need plenty of room to write my tangent because tangents take a little more space. So we have our formulas down. Sine of u. Remember, this is u, and that's v. The sine of u, the cosine of v, in this case, is going to be 30 degrees. The sine is the same. The SIGN is the same. The sine of 30 degrees and the cosine of 315 degrees. And again, page 400 is the place that is all sort of recapped. Now let's change out the values. We know what the sine of 315 degrees is. So 315 is right there, and 30 degrees is right there. So the sine value would be negative square root of 2 over 2. The cosine value is square root of 3 over 2. The sine is right there. Let's just put in our ordered pairs just so everybody's really clear. Okay, so the sine value, the y value is a half, and then the x value of the cosine of 315 is square root of 2 over 2. And that leads us to multiply this out. We get the negative square root of 6 over 4 minus the square root of 2 over 4. And we're going to go ahead and take out a greatest common factor. So what radical is common in the top? And that would be the square root of 2. The denominator that's common would be 4. Now, do you want to take out a negative on this one? A negative square root of 2 over 4, or leave it as a positive? Really, the choice is yours. My general rule is if they're both negative, I'm going to go ahead and take out the negative, leaving behind the square root of 3, technically over 1, plus 1. And that is the sine of 315 degrees minus 30 degrees. Cosine, same thing, page 400 gives us the formula. U is going to be 315 degrees and V is going to be 30 degrees. Cosine's a little different because it goes cosine of 315 degrees, cosine of 30 degrees, and the parentheses are optional on this one. You don't have to have them, so I'll go ahead and take them off. Okay, it's all glued together with multiply, but the one trick is the sign for cosine is always opposite of whatever you see. Now we're ready to continue, and it's the sine of u and the sine of v. And again, page 400 has all the formulas listed out, and so you can choose to memorizing those would be your best option. So let's draw 315 again, just to have everything lined up. 315 was down here, 30 was right there. So we're still going to be using some of the same ordered pairs. And the cosine of 315 degrees was square root of 2 over 2. It's positive to the right. The cosine of 30 degrees was the square root of 3 over 2. The sine of 315 degrees is negative square root of 2 over 2. And the sine is negative 1/2. So that gives us positive square root of 6 over 4. Plus, and these two negatives are going to make a positive, square root of 2 over 4. And so, again, same question, greatest common factor for the numerator. The greatest common radical is the square root of 2. The greatest common denominator that's going to come out is 4. So that's my greatest common factor in front. And the square root of 2 multiplied by what makes the square root of 6? Okay, square root of 3. And the square root of 2 multiplied by what makes the square root of 2? And we're all set. So the tangents, we're going to go ahead and just bring those down all the way to the bottom here. We don't have enough room. Let's bring those all the way down for the ride here. So give yourself plenty of space, and I'll give you some time to get set up. Okay, so the tangent formula. Tangent of u, same sign as what you see, minus the tangent of v, which is 30 degrees. And again, page 400 has all of the formulas listed out. Minus, or sorry, excuse me, 1. And then we do the opposite sign of whatever was there, so plus, and it's the tangent of u multiplied by the tangent of e. So that gives me, now this one's a little bit more difficult because they're tangents. So let's get our tangents written in there. This would be the square root of 3 over 3 for my tangents, and it would be positive because the slope is rising and running to the right. This one's clearly negative. It's a negative slope. And this one is on the 45, so it's a slope of -1. So the tangent, let's go ahead and use a lot of parentheses on this one. The tangent of 315 degrees is going to be -1. The tangent of 30 degrees is going to be the square root of 3 over 3. And down here, this is going to be -1, and this is going to be the square root of 3 over 3. So to make our lives just a little bit easier, we'll go ahead and rewrite this in a way that is a little bit easier to see, less parentheses. And what is the product of that? Okay, so it'd be just a negative version of it. Now, this looks intimidating, but just a couple of steps is going to make this look a lot easier. Well, these are fancy versions of 1. And now we've created common denominators, and so we can, for the numerator, this whole big thing can be simplified down just a little bit. So let's take a look at what that might look like. -3 minus the square root of 3 over the common denominator was 3. And that's this whole portion simplified. Now we're going to do the same thing. We're going to do this whole portion. We're going to simplify over there. Complex fraction, big old denominator, 3 minus the square root of 3 over 3. Now you're actually one step away from having everything sort of work out pretty nicely. The numerator stays exactly the same, and we're going to multiply by the, what are we going to multiply by down here? All connected here. Multiply by the reciprocal of the denominator, so it'd be 3 in the numerator now, minus, or 3 minus the square root of 3. And what happens with those 3's, and all of a sudden it's going to get a lot better here, they're gone, leaving us with -3 minus the square root of 3 over 3 minus the square root of 3. So what we're going to do now is we're going to multiply by, to clear out that radical in the denominator, we're going to multiply by the complex, or excuse me, just the conjugate. So we're going to rationalize the denominator, and how we do that, we just look at this sign right here, and we always do the opposite. So the conjugate, and it's a big fancy version of the number 1, is 3 plus the square root of 3 over 3 plus the square root of 3. Now we're going to go ahead and do a whole bunch of distribution in the numerator, which gives me -9. Let's do my outers. Minus 3 square root of 3. Do the inner. Minus 3 square root of 3. Do the outer. Minus 3. All over. Now this is a conjugate, so we don't have to FOIL. We can just F and L, because the O and the I are going to cancel. So just the first and the last are going to produce something. So 3 multiplied by 3 is 9. Minus the square root of 3 multiplied by the square root of 3 is 3. getting close here. This is probably the most tedious question on the entire test. But once you make it through this, you're finished. Negative 12 comes from that. And then we'll combine like terms right here and right here. And so how many square root of 3's do we really have? Okay, negative 6 square root of 3 all over 6. Let's look to see if we can reduce, and we can divide negative 12 and negative 6 by 6, leaving, in this case, negative 2 minus the square root of 3. And that's it. So question 1 takes the longest out of the whole packet, and question 2 is probably going to take just about as long. But after that, then it really begins to speed up. So we're going to come back to question 2 in just a minute because we're going to try some different questions, and we'll come back to 2 because, again, it takes a while. But that runs you through all the different sum and difference formulas as you go. And again, page 400 is the big part on that. So we'll come back to 2 in just a little bit. All right, so let's do some faster questions. Write the expression as the sine, cosine, or tangent of an angle. What you'll notice about this one's almost like it's been laid out already. It already has been broken up, and so what you would need to do is just answer a few questions. Is that a sine question, or is it a sum and difference for a cosine or a tangent? Well, it has sine and cosine and sine. We can tell that it's a sine question. And the reason why, you have sine and cosine and sine, just like the formulas on page 400. So what do you think u is? Well, this one comes first, so the normal way of doing it is that's u, and v is going to be 45. So in this case, u is 60 degrees and v is 45 degrees. And what happens for the SIGN on a sine function for sum and difference? Well, in this case, it's a difference question, so the sign is exactly the same. The actual negative, you get a negative sign. It's subtraction. It's a difference question. So really, this is the sine of, in this case, 15 degrees. Now, can you actually find the exact value for the sine of 15 degrees in terms of the unit circle? No. So, and you'll notice it just says write the expression as the sine, cosine, tangent of an angle. And we've written it as the sine of 15 degrees, and 15 degrees, of course, is the angle. For question 4, I'm going to give you 10 seconds here. I want you to identify, is that a tangent question, a sine question, or a cosine question? If you figured that out already, start to think about, is it a sum or a difference question? What's u? What's v? So this one's pretty easy to tell that it's a tangent question because it's the only one that looks like it, and it has tangent all over the place. So is it a sum or a difference question? And tangent always is the same on the top, so that's a sum question. U is 25 degrees and V is 10 degrees, and so we end up with the tangent of 15 degrees. Are we actually able to find the exact value of that one? Nope. Tangent of 30 we could, sine of 30 we could, but not the sine or the tangent of 15 at this point in time. So question 3 pretty short, question 4 pretty short, question 1 half a page of work. So there's a lot of, it really depends on the question that you're answering. 5 and 6. Now the words on this are slightly different than 3 and 4. 3 and 4 said write the expression of an angle. This one says find the exact value of that particular expression. So we're going to do the same sort of skill, but just take it one step further. So in question 5, we have to, one, identify. I think you're probably getting pretty good at this. Is this a cosine or a sine question? Well, that one has cosine, cosine first, so it's a cosine question. What's the u value? In this case, it'd be 15, and the v value is 60 degrees. Now, what's a little misleading is this is the only time we have to be careful. And again, on page 400, the formulas, anytime that was a plus sign, it was actually going to be a what in the actual question? It's going to be subtraction. So really, we have the cosine of negative 45 degrees. Now, can we do the cosine of negative 45 degrees? Sure. We just go clockwise, and in this position right here, the cosine of negative 45 degrees is square root of 2 over 2, which is the exact value. That's exactly what it is. For question 6, I want you to take a 15-second head start here. 25, 20, and it has a subtraction sign in a cosine question. So it's clearly going to be cosine. If it's subtraction and cosine, that means it's a sum question, because it's the only one that's opposite. 25 is u, 20 is v in terms of degrees, giving me the cosine of 45 degrees, and it's actually positive this time. Well, the cosine of 45 degrees is right there, and because it's all about the x values for cosine, this one's still going to be what as well? Square root of 2 over 2. So 5 and 6 build off of what you're doing in 3 and 4. And again, these are somewhat short compared to what you were doing in question 1. Okay, find the exact value of the trigonometric function given that the sine of u is 3 over 4 and the cosine of v is negative 5 over 13. Okay. Same way that we sort of practiced this, the sine of u is the angle, cosine of v is a different angle. Well, we notice that 3 and 4 and 5 and 13 can't be all in the same triangle. If there was some overlapping with those numbers, maybe they could fit on the same triangle, but in this case, you actually are going to need 2 different triangles. It helps us out. Both of them are going to be in quadrant 2. This is u, and we'll draw another one down here from the perspective of v. So let's just start labeling the triangle with the things that we know. The sine of u is 3 over 4. Okay, so I know that the opposite side of u is 3, and that the hypotenuse is 4. Now, let's find the third side using the Pythagorean theorem. Now, a lot of students want to get excited and think, well, wait a minute, that's a 3, 4, 5 triangle. But if you put a 5 right here, is that actually true? Is 4 the longest side if the other leg is 5? No, it doesn't work. So unfortunately, that's not true. We need to do the Pythagorean theorem and show our work on this one. 4 squared minus 3 squared equals the unknown side squared. So we get 16 minus 9, which is 7, equals x squared. So this is actually the square root of 7. 16 minus 9, square root of 7. Next, we have negative 5. Cosine is negative 5, so we have the adjacent, negative 5 over 13. And remember, the hypotenuse is always positive. So as you look at this, is that one a Pythagorean triple from the perspective of angle V? And it is. This is a 5, 12, 13 right triangle. Okay, so the V was actually a little easier than U, but we kind of made our way through it. So now what we need to do, we need to actually answer the question, which is the cosine of u minus v. Well, the formula is cosine of u, cosine of v, plus the sine of u, sine of v, and that comes from page 400 again. It's just a straight formula, difference. And all we're going to do is pop in the values, substitute in the values from the triangles that we have. So what is the cosine of angle u? And in this case, it's going to be, the cosine is going to be square root of 7 over 4. Okay, so as we look at this now, we're going to go ahead and substitute in the values. And for the cosine of u, that was the square root of 7 over 4. For the cosine of v, I'm going to change over to red here since I'm on the red triangle now. That was negative 5 over 13. Switch back to the green here. The sine of u was 3/4, and heck, they even told us that at the top there. Same with the cosine of v. Switch back to the red, and the sine of v would be 12/13. So now we just have to multiply across and kind of combine, like, or make common denominators if needed. But good thing is they already do it for us. Gives me -5 square root of 7 over 52 plus 36 over 52. And unfortunately, they don't combine, other than I can do 36 minus 5 square root of 7 over 52. Now, you could reduce 36 and 52 and kind of keep them separate. That's fine. You could also combo it here. That's fine. I'm going to go ahead and reduce it just because you can, but I would really be fine with an answer like that. So we'll put an or right here. And so as we reduce this one down, you could divide everything by definitely 2. So 18 over 26, divide everything by 2 again, 9 over 13. So another answer would be 9 over 13 minus 5 square root of 7 over 52. That would be another answer. Completely simplified, but I'll give you flexibility on that one. Now, there was another question that was built off the same thing. It was actually question 8. So it's a very similar question. It just is going to specifically ask for the tangent of u minus v. So let's write that down at the bottom here, just so we're organized. The tangent of u minus v. So it's a difference question. So using the formulas from page 400, we know that it's going to be u minus v over 1 plus the product of u, tangent of u and tangent of v. Well, the good news is, let's switch back to green and red again. Let's look up at the green triangle. I'll give you a second to get organized here. There's the formula from page 400. Let's scroll up to the top here. Okay, green triangle, tangent of u, opposite over adjacent. So it's going to be 3 square root of 7 over 7. Now remember, I'm rationalizing the denominator, kind of that skill that we've been practicing pretty much all year. So time to kind of speed it up just a little bit. That was opposite over adjacent. Now I'm in triangle, the red triangle, so I'm going to do the tangent here. And the tangent is going to be -12 over 5. And now that we have that listed, we can kind of just go right here because it's the tangent of u again. And now the tangent of v again. Now, you have a lot of negatives here, so let's just kind of map this out. Both negatives should actually come out to be a positive. So this gives me 3 square root of 7 over 7 plus 12 over 5. This one gives me 1 minus, because a positive and a negative are going to make a subtraction sign. And now all of a sudden this is going to have a little more going on. 36 is 3 multiplied by 12, square root of 7 over 35. So unfortunately, we do need to make some common denominators here. In the numerator, the common denominator is going to be 35. So that gives me 15 square root of 7 plus 84 all over 35 all over, give you time to make sure you're there. This is 35 over 35, change around our fancy version of 1. And it's going to get just a little better here. All over 35. Now, we're going to multiply by the reciprocal of the denominator, which gives us 15 square root of 7 plus 84 over 35, multiplied by 35 over 35 minus 36 square root of 7. And the 35s are going to reduce out, leaving behind 15 square root of 7 plus 84 over 35 minus 36 square root of 7. Now, for this question is starting to get a little bit larger here. Okay, so we're going to go ahead and multiply by the conjugate. Now, something I just want to do, because the questions are, these are sort of a little bit longer, especially the tangents. I want to scroll all the way back up. When you're building these questions, it's really important to make sure that you have your signs right for the extra portions that you add on the triangle. And I kind of got this feeling that half my tangents were negative and then half my tangents were positive. Well, if you're drawing them from the same quadrant, that doesn't really make sense. And so you probably caught this a little earlier. That should have been a -7. Now the good news is most of the work is exactly the same, but I do need to go back through and just make a couple quick updates. And again, I probably should have checked that sooner, but that's the problem of making a video. You can't go back and really edit using this format too well. All right, so this becomes a negative right there. That's the only thing that changes. So instead of this part right down here being negative, what should the sign be on that one? Okay, so it should be a positive. Not a big change, but it does make it a better answer. And that kind of carried over to this part right here. So let's change that from a negative back to a what? Okay, so that's a positive. And again, that carries down here to the denominator, or remember how we had two different answers for the or, so that becomes a positive. So not too much of an issue by missing the sign there, but man, it's so important to check that. Normally I check it on the front end, saves me a little bit of heartache and headache. Let's jump back in and get these all lined up. So where else will it have an issue? Right down here. That should be negative, and that should be a negative. So it's just going to change our signs just a little bit. And again, if this is throwing you off too much by having it changed, then I can certainly walk through it with you in person. But it's a good reminder to check that early and check it sooner than later. So really not too much changes in the numerator, except that this part is negative, which means that this part is what? So that's not too big of a change. Now down here, what is a positive multiplied by a negative multiplied by a negative? That's actually going to be a what? Okay, so positive, and that carries over right to here. We're almost done fixing. Thanks for your patience with me. This part right here should be negative, and this part right here should be positive, leading us to the final little step right here. Basically, that should be negative, and that should be positive. Okay, so now we're ready to multiply by the conjugate, which would be 35 minus 36 square root of 7. And we're making a fancy version of 1. And now right here, we're going to put stop. This question sort of trails off. I have the worked out solutions online if you want to follow it more. But a question like this is really realistically going to be a little bit worse than what we work with traditionally. So most of our tangent questions kind of resolve themselves fairly quickly with the conjugate. But this one, unfortunately, is going to have to go a lot further, especially when you start to expand this out and multiply that out, the numbers just get so large. So you can follow the worked out solution on Canvas, but realistically, on a test or an assessment, we're not going to have something that goes that far in. But we practice the skill of drawing the triangles, and showed you there. I highly recommend checking them sooner than later. And then also, we did that with the cosine of u minus v and the tangent of u minus v. So one of them, the cosine was very, very short and simple. The tangent kind of holds true all the way throughout the test. This one, tangent's a little bit more challenging. Okay, so let's go back over to some different types of questions. Now these questions look intimidating, but the good news is that these are really pretty user-friendly. Find all of the solutions of the equation in the interval from 0 to 2 pi. 2 pi is non-inclusive, and 0 is. So is this a sine question or a cosine question? Well, this part right here is clearly a sine. Is it a sum or a difference? Well, that's a sum, so it would be the sine of x cosine of pi over 4 plus the sine of pi over 4 cosine of x, because x is u and pi over 4 is v. Now, these are sort of long in terms of writing them out horizontally, so we'll do 10 below it. Subtraction sign comes into play because I'm simply just bringing it down. Now we're going to do the same procedure, except now all of a sudden this is a difference question. So it's the sine of x cosine of pi over 4 minus the sine of pi over 4 cosine of x, and that equals 1. So it looks pretty intimidating, but I want to add one more thing here. Now technically, it was subtracting this whole thing. That's what it was subtracting, so I think it's worth putting the parentheses in to keep that organized. Now, a couple of things that students like to do, they like to distribute the negative to both parts. So we end up with the sine of x cosine of pi over 4 plus the sine of pi over 4 cosine of x minus the sine of x cosine of pi over 4 plus the sine of pi over 4 cosine of x equals 1. Now, let's make some observations. What do you notice about those items right there? They are exactly the same, and when you subtract them, it creates a fancy version of 0. Next, you notice that these terms are exactly the same, and how many of them are there? 2 of them. And that equals 1. So, next, what is pi over 4? Or sorry, the sine of pi over 4. Okay, so pi over 4 is right here, and that would be square root of 2 over 2. Well, 2 divided by 2 is 1, and 1 multiplied by the square root of 2 is the square root of 2. Now, what should we do to solve for x? Okay, let's divide both sides by the square root of 2. The cosine of x equals 1 divided by the square root of 2. Let's rationalize the denominator. And where is the cosine of x square root of 2 over 2? And where else? Excellent. And so from 0 to 2 pi, the answer would be pi over 4 and 7 pi over 4. Perfect. And that comes from a long string of horizontal writing out and sort of simplifies down into content that was like we learned in the last test and the test before. So let's bring question 10 down now. Let's bring 10 down. Okay, so this is definitely going to be from the perspective of cosine. And so let's just deal with the first one, the cosine, and it's a sum. So if it's sum, it's going to be subtract. X is u, and v is pi over 6. So now we're going to subtract this part right here. which would be the cosine of x, the cosine of pi over 6, and if it's subtraction, it's addition. All right, so let's do the distribution just like we did before, and I'll give you about 10 seconds here to get caught up with the writing, and then go ahead and move into the distribution. Okay, so we get the cosine of x, the cosine of pi over 6 minus the sine of x, the sine of pi over 6 minus the cosine of x, cosine of pi over 6 minus the sine of x, the sine of pi over 6 equals 1. Let's just make sure we have everything lined up in terms of our signs. I'm checking the original, checking my blue line, my green line. That looks really good. Now I'm checking my red line, and that looks good. So let's try to combine like terms now. These questions are designed to work out nicely. That makes a fancy version of 0. And this makes a fancy version of, how many of them are there? There are 2 of them. They're both negative. And so we're kind of back to something that gets a whole lot more user-friendly pretty quickly. Okay. I like to rewrite this part like this. And then let's actually figure out, what is the sine of pi over 6? It's a half. Oops. Now we can reduce the fraction, and this gives me negative sine of x equals 1. So let's divide both sides by. Let's divide both sides by -1, or multiply by -1. And the sine of x equals -1. Where does that happen? It happens at 3 pi over 2. Okay, kind of on the downhill stretch here. Now we're moving into some of the double angle formulas. These are located on page 407. Now, how do you know it's a double angle? Well, the 2 gives it away that it's 2, in math is another way of saying, you double something, multiply by 2, and 2u, and so basically this is a small modification. Instead of it being u and v, now all of a sudden it's u and u. Well, if it was u plus u, we could just condense it and just write the tangent of 2u. Now, each of these items have formulas. In this case, the first one is the 2 multiplied by the tangent of u, 1 minus the tangent squared of u. And we'll actually build those on a different question, but those are the formulas from page 407. So really what we're going to do is we're going to do 2 multiplied by something, 1 minus something squared, and that something is going to come from our triangle up here. We are 2 spaces to the right, so it's positive. You're 5 spaces up. Notice I'm not going to make a mistake with my signs. And so we need to find the third side of this right triangle, so let's do the Pythagorean theorem. 2 squared is 4, and 5 squared is 25, so this is the square root of 29. Now, for question 11, it needed tangents. I really didn't need the square root of 29 for this part, but that's okay. So tangent is opposite over adjacent, so it's 5 over 2. 5 over 2, and it's all positive. Giving me, reduce that fraction, 5 in that numerator. And we're kind of breaking out all of our moves here. 1 minus 25 over 4. So we squared 5 and we squared 2. Well, let's turn this into 4 over 4. So we have common denominators, which now gives me 5 over negative 21 over 4. Now don't forget that technically 5 was over what? You're 1 step away from being finished. 5 over 1 multiplied by the reciprocal of 4 over negative 21. gives you 20 over negative 21. And so the tangent of 2u is negative 20 over 21. Now I know you're thinking, well, I don't have a secant formula for the double angle formula. So what we're going to do, secant is really just going to be 1 over the cosine of 2u. Now you do have a formula for the double angle of cosine. So what I'm going to do is I'm going to do the whole problem from the perspective of cosine, and then at the very end, do the reciprocal. So cosine, the most commonly used version of cosine is cosine squared of u minus the sine squared of u. And so let's take a look here. Cosine is going to be 2 squared of 29 over 29. I rationalized the denominator. It was 2 divided by the square root of 29. And then I'm going to do the sine, which is going to be 5 square root of 29 over 29. And that's squared as well. Now, what's nice about these types of questions, they actually work out really, really well. So this is going to be 4 because it's 2 squared, and the 29 gets squared, but it's the square root of 29, so it actually just comes up as 29 over 29 squared. That's the first parenthesis being squared. Why don't you try the second parenthesis being squared? Five squared is 25. Square root of 29 squared is 29. And 29 squared is 29 squared. Now I'm not going to use a calculator on this because they're designed to work out really well. Now here's what happens. There's a 29 upstairs and 2 of them downstairs, so there's only 1 in the denominator. There's a 29 upstairs and 2 29s downstairs, so what's left over is just a 29 in the denominator. Really, you have 4 over 29 minus 25 over 29, giving you negative 21 over 29. That's a cosine answer. So what would the secant's answer be? Well, let's do the reciprocal of that, and we would get 29 over 21, and it would be negative. Built from a triangle, following the formulas on page 407, and using the algebra that we've worked on. (13) and 14. Now, you kind of are tipped off to these double angles. That one has a double angle. That one has a double angle. So let's see what we can do. Now the sine of 2x, again the formula is on page 407. So this would be 2 sine of x cosine of x. So I just substitute that in directly. That's what it's worth. And you know, I don't think you'd be able to wake up one day and come up with that. You really need to sort of see that build from page 400 to 407. Now, what could you do in terms of algebra now? Well, let's look at this. You have a binomial. I can't help but notice that both terms in the binomial have cosine. So let's take a cosine out of this as our greatest common factor. And now we're actually completely factored. The glue between the two terms is multiplication. And so let's set each factor equal to 0. So let's go ahead and solve. Well, the first part's already finished. Where is the cosine equal to 0? Right there. And right there, the x values are equal to 0. Over here, we're going to add 1. 2 sine of x equals 1. So the sine of x equals a half. Where is the sine of x a half? Right there. And right there. Let's put it all together and answer the question. X would equal pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. Next question. Let's change this to something. Cosine squared of x minus the sine squared of x minus the cosine of x equals 0. And again, that's straight from page 407. I'm just doing a basic substitution with what the double angle of cosine could be worth. Now, as you scan through the question, can't help but notice that someone's sort of the odd man out. Is it cosine or is it sine? Well, it seems like you have two cosines. It's kind of like one right there, one right there. So it seems like sine is the one that's sort of misplaced. So is it possible to change sine squared into something that might be related to cosine using one of our identities? Well, sure. It's 1 minus the cosine squared of x. Let me slide this over here so I have plenty of room. Minus the cosine of x equals 0. Well, let's combine like terms. Distribute the negative. I actually end up with 2 cosine squared of x because that bounces back to a positive. Minus the cosine of x minus 1 equals 0. And I can't help but notice that I'm going to be left with a trinomial on the left or on this left side of the equation. So slide this over a little bit. Let's get my c back on cosine here. So we have a trinomial that we can factor. 2 cosine of x, 1 and 1. Okay, let's see if I can get my signs correct here. This should be a negative and a positive. Go ahead and check that with a quick FOIL. That gives me 2 cosine squared of x minus 2 cosine plus a cosine gives me the negative cosine x in the middle. And negative 1 and 1 multiplied make negative 1. So now we have it multiplied out. Each factor is glued together with multiplication, so we can set it equal to 0. So let's solve each portion. Subtract 1 and divide by 2, and I get the cosine of x equals negative 1/2. And the cosine of x equals 1. So let's draw a little circle for ourselves here. Where is the cosine negative 1/2? And where is the cosine 1? Now, we're not allowed to write 2 pi for this one. Go back up to the instructions. 0 is inclusive. 2 pi was non-inclusive. So x is going to be 0. X is going to be 2 pi over 3. And finally, x is going to be 4 pi over 3. And that content uses the double angle formulas and loops us back to the content that we worked on in the last chapter. All right, last thing. Getting close here. So using those double angle formulas on page 407, it's possible that you can sort of rewrite them around. We can also use them to verify identities. We can do a couple of things with them. Well, the first thing is, let's look at 15. You don't have to know exactly what's going on to sort of be able to pick out that you could do something right here. You could definitely take out a greatest common factor of 6, which leaves behind 1 minus 2 sine squared of x. Now, what happens here, we'll probably actually come back to this one. Let's put a star on that one. Taking out the greatest common factor is what we can do, but I want to come back to that one just to make sure it's crystal clear. Some of you have your page open to 407. You already see what the answer might be, but let's just hold off on that one just for a moment here. Let's do distribution here. We get sine squared of x, and I can't help but notice that it's a conjugate, so the outer and the inner should cancel, but let's just write it out for fun here. And a lot of you are seeing it right now. Yep, they canceled. And then the last portion, what is cosine multiplied by cosine? Okay, cosine squared of x. So really, that part cancels with that part, making a fancy version of 0. And I get the sine of squared of x, sine of x squared, excuse me, minus the cosine of x squared. And we've written that out quite a bit. This thing's actually worth what? It would be the cosine of 2u, but there's a small change here. Technically, there's a negative out in front of it, and it would be the cosine of x squared minus the sine of x squared. So really, I've changed it to a u. That's what the book has all the time. And so it's really just going to be a negative version of that. So we'll come back to 15 to finish that in just a moment here. I'm going to skip to this one. Okay, so this is a big part of what we're going to do on the test. Use the sum formulas to generate the double angle formulas, just like we practiced. Also show why the cosine of 2u has 3 expressions that are equivalent, which is going to lead us back to that question that we were just working on. Okay, so let's just get started. The sine of u plus v is my traditional sum formula, which was the sine of u, cosine of v, plus the sine of v cosine of u. So that's the page 400. How do we get to page 407? Well, there was an assumption that we would kind of kick off the v and place in another u, which really gives me the sine of 2u. And now all of a sudden, if you really look at that, kind of switch them around using the commutative property of multiplication, you really have 2 sine of u, cosine of u. And that is the double angle formula for sine on page 407. So you build from page 400 to 407 by substituting in a u for v. Let's do the same thing for cosine. And that equals the cosine of u and the cosine of v, minus the sine of u, the sine of v. Change the v to a u. Wrong one. And on this one, we notice we get cosine multiplied by cosine, so it's the cosine of u squared minus the sine of u squared. So it's cosine minus sine, and that equals the cosine of 2u, which looks similar to the question that we just sort of finished before, except it was sort of opposite of that. It was a positive sign and a negative cosine, which is why we needed to change that to a negative cosine of 2u. Now, on this one, let's finish the question. Why are there 3 versions for the cosine of 2u? Well, right here, using our Pythagorean identities, it's possible to put what in that place. It's possible to do 1 minus the sine of u squared minus the sine of u squared. And so the other version is, well, kind of change this over to red here. What if we actually did a Pythagorean on that one? Well, that cosine would stay the same, cosine of u squared, minus 1 minus the cosine of u squared. And so that would actually be the cosine squared of u minus 1 plus the cosine squared of u. So let's condense these down. So in green, really what you have here is the cosine of 2u is 1 minus 2 sine squared of u. In red, condense it down, you have the cosine of 2u is 2 cosine squared of u minus 1. But don't forget, kind of over here in blue, you had the original one that everything is built from, and that was the cosine of 2u equals the cosine of u squared minus the sine of u squared. So those are the 3 versions of cosine using the Pythagorean identities that we did before. Now the tangent of, that's tau, the tangent of u plus v is going to be very similar. We're going to cross out the v, switch it with the u, and that was the tangent of u plus the tangent of v, having trouble here, over 1 minus the tangent of u multiplied by the tangent of v. So let's get rid of all the v's and substitute in u. And what you notice is you're going to end up with the tangent of 2u, and that's going to equal 2 tangent of u in the numerator, because we just add a tangent of u plus tangent of u is 2 tangent of u. 1 minus the tangent of u multiplied by the tangent of u is going to give you the tangent of u squared. And that is the double angle formula for tangent. So read the instructions one more time and see if that makes sense. Okay, so let's go back to where we were just a moment ago. And let's see if this clicks now. So what do you actually have written right there? You actually have the cosine of what? And you're done. And again, look at this with fresh eyes. Doesn't it make sense why this part right here needed to be a negative 2 cosine of x? Because it's completely and totally opposite of what it should be for the cosine of 2x. Okay. All right, so let's do some verifying before we get to that. I think that's about everything. Cosine or cosecant of 2u, we want to verify that that equals the cosecant of u over 2 cosine of u. Well, the first thing that we're going to want to do is really think about that part right there. We don't really have a double angle formula for cosecant, but cosecant is really 1 over the sine. So what we're going to do is we're going to do this. Or we could just take the reciprocal for the sine of 2u. So in this case, the sine of 2u is 2 sine of u, cosine of u, and instead of being in the numerator, it's actually going to be in the denominator. So we did 1 over the sine of 2u. So this gives me 1 over sine. Let's look at this part right here. 1 over sine is really what? Because this is all multiplication. That gives me, good, the cosecant of u, because 1 over sine is the cosecant, 2 cosine of u. And it looks kind of intimidating, but our left side matches our right side, doesn't it? And we're done. And that worked because everything was already what? Not added together, because that would have been a lot of work, but multiplied together. So we were able to sort of pick apart the ones that you wanted. It's really like saying 1/2 multiplied by the 1 over the sine of u multiplied by 1 over the cosine of u. That's really what it's saying. So maybe that would be easier to sort of see what's being presented there. Okay. All right, so now here comes one of the big parts on the test. This is a big part to be able to find the exact value of the sine of 2u, the cosine of 2u, and the tangent of 2u using the double angle formulas. Now in these questions, they tell you where to draw the triangle, and we're going to make sure that we draw correctly, label correctly, do everything correctly. So we're in quadrant 3. Sine is opposite over hypotenuse. What kind of should the 4 be negative or the 5 be negative? Well, this one's going down, and hypotenuse is always positive, so that's negative. Let's do the Pythagorean theorem. This is a 3, 4, 5, and we went left, so it should be a -3. Now, once you have the formulas on page 407 down, actually finding this really isn't too bad. The sine of 2u is 2 sine u cosine u. The sine of u is going to be -4/5, and the cosine is going to be -3/5. And so that comes up as 2 multiplied by 4 is 8, multiplied by 3, 24, and it's positive over 25. You cannot reduce that, and that is the sine of 2u. The cosine of 2u equals cosine squared minus sine squared. Well, cosine squared was negative 3/5, and the sine squared is negative 4/5. So let's go ahead and square this. You get 9 over 25 minus 16 over 25, and that gives us negative 7 over 25. I'm going to kind of come over here to the right because we're going to have to rewrite our question for 18 down below. And for this one, we end up with the tangent of 2u. We'll bring 18 down to the bottom and start new triangles and everything, so I'm still finishing up 17. The tangent of 2u equals 2 tangent of u over 1 minus the tangent of u squared. Well, the tangent of u, let's look over to the triangle on the left, is opposite over adjacent, so it's actually going to come back to being a positive 4/3 because the negatives cancel. And for once, tangent isn't going to be too terrible here. We end up with 8 over 3 over 1 minus 16 ninths. Let's change this to a common denominator, giving us 8/3 over negative 7 over 9. Let's multiply by the reciprocal. 8/3 multiplied by 9/7, and it's negative. Finally giving me, let's reduce that to a negative 3, negative 24 over 7. I'm going to let you get a head start here on drawing the triangle for the cosine for number 18. Cosine of u equals negative 2 over the square root of 5. Cosine is adjacent over hypotenuse, and you're going to be drawing that in quadrant 2. So we're going to do negative 2 over the square root of 5. So let's break out our Pythagorean theorem here. And we end up with square root of 5 squared minus negative 2 squared equals x squared. And so we end up with 5 minus 4 equals x squared. So x is going to be the square root of 1, which means x is 1. And just check it. 1 squared plus 2 squared is the square root of 5. Okay. I'd hate to see a mistake take place because of the Pythagorean theorem. So this part is 1. And we're going to do the same procedure again. We're going to do 2, the sine of 2u. The cosine of 2u was cosine squared minus sine, sine squared. And then we'll do tangent down here at the bottom. The tangent of 2u was the tangent of 2u, so that was 2 multiplied by the tangent of u, 1 minus the tangent squared. So I like to just make parentheses to put all of them in using those formulas from page 407. If you need to get caught up here, go ahead and hit pause. All right, let's get started. So for the first one, we're going to do the sine, which is, now I'm going to rationalize the denominator quickly here. Square root of 5 over 5. The cosine is going to be negative 2 square root of 5 over 5. The cosine is negative 2 square root of 5 over 5. I'm just filling them in right now. And the sine is going to be square root of 5 over 5. Let's go down to tangent, just fill it in. The tangent, hey, this one's pretty nice. It's just negative 1/2. And now I'm ready to actually do the work. Okay, so this becomes negative 4 multiplied by 5 over 25, which is just negative 20 over 25. The next one comes up as 4 multiplied by 5 minus 5 over 25 over 25. And that gives me 20 minus 5, which is 15 over 25. And that one finally does reduce. So that one gives me, reduce that fraction, 3/5. And now tangent, remember this is 2 over 1, so that reduces, leaving what in the numerator? Negative 1 over 1. And in the denominator, I get 1 minus, this part right here becomes positive, and it's 1 over 4. So let's create common denominators. 4 over 4 minus 1 over 4 gives me 3 over 4. Let's multiply by the reciprocal here. We get negative 1 over 1 multiplied by 4 over 3. And my answer is going to be negative 4/3. Okay, let's make sure we've gone through everything. Oop, here's another one. Verify the identity. Let's look at it from the perspective of that being u and that being v. The sine of u, cosine of pi over 2, minus the sine of pi over 2, cosine of x. What is the cosine of pi over 2? Cosine of pi over 2 is 0. The sine of pi over 2 is what? 1. And this part right here is nothing. It's a big fancy version of 0, leaving behind negative cosine of x equals negative cosine of x, which is exactly what you wanted. Okay. And I think the only thing that we have left to do is question, yep, we did 8 all the way down there. The only thing left to do is question 2. And this will take a decent chunk of time here. It's just kind of a heavy question with a lot of steps. Hopefully we can go a little faster now that we've been practicing sort of these skills. So question 2 is coming on down for the ride here. And again, the sine and the cosine, not so bad. The tangent is a little bit more work. Okay, well, let's see if we can kind of speed up maybe just a little now. We're going to do the sine of u plus v. Again, this is not a double angle. We're back to just, this, obviously these two items are not exactly the same. That's a u and a v, not u and u making 2u. They're not the same. Okay, so this is a sine problem. This is 11. These are the formulas on page 400. 11 pi over 6 cosine pi over 4 plus the sine of pi over 4 cosine of 11 pi over 6, and that equals the sine of 11 pi over 6 plus pi over 4. So it's sine of u plus v. Draw your pictures. 11 pi over 6 is right there, and pi over 4 is right there. Our ordered pair would be square root of 3 over 2, comma, negative 1/2, and square root of 2 over 2, comma, square root of 2 over 2. Okay. The sine of 11 pi over 6 is negative 1/2. Cosine is negative square, or excuse me, square root of 2 over 2. The sine of pi over 4 is square root of 2 over 2. And the cosine is square root of 3 over 2. And this is going to equal negative square root of 2 over 4 plus the square root of 6 over 4. And again, we have that same sort of skill where we have the greatest common factor coming out in front. That would be square root of 2 over 4, which is nice because it really hasn't changed much. We've seen that over and over again, leaving behind negative 1 plus the square root of 3. And that is the sine of 11 pi over 6 plus pi over 4. All right, cosine. Cosine of 11 pi over 6 plus pi over 4 is going to be cosine of u, which is 11 pi over 6, cosine of v, minus the sine of 11 pi over 6 sine of pi over 4. Cosine of 11 pi over 6, we can look up at our unit circle in the top left corner here, square root of 3 over 2. And the cosine of pi over 4 is square root of 2 over 2. Minus the sine 11 pi over 6 is negative 1/2. And the sine of pi over 4 is square root of 2 over 2. Double check that. It's good. And we end up with the square root of 6 over 4, which we've seen quite a bit now, plus square root of 2 over 4, which gives me square root of 2 over 4, square root of 3 plus 1 as my answer. And now, last but certainly not least, good old tangents. The tangent of 11 pi over 6 plus pi over 4 equals the tangent of 11 pi over 6 plus the tangent of pi over 4 over 1 minus the tangent of 11 pi over 6 multiplied by the tangent of pi over 4. Okay, so let's draw our unit circle. 11 pi over 6 right there, and pi over 4 right there. So let's think tangents now. Not very steep and negative, and just normal, medium, and it's 1 and it's positive. So we end up with negative square root of 3 over 3 plus 1 over 1 minus negative square root of 3 over 3, 1, giving me, let's do our trick with common denominators again, making fancy versions of 1. Negative square root of 3, you know, I'm gonna change that. I like my constant portions that are integers to come first. I'm making a mistake on my sign, I'm sorry. 3 minus the square root of 3. Basically, I took this and brought it in front. Over 3. All over, now visualize this, that's going to be a negative, and that's going to be a negative and a negative, so that whole thing's going to be plus. 3 plus the square root of 3. Three plus the square root of 3 all over 3. Now, we can rewrite it and multiply by the reciprocal, or, you know, at this stage of the game, we can make your life just a little better with your tangents because you know those are going to reduce anyway. Leaving behind 3 minus the square root of 3 over 3 plus the square root of 3. Now you're 1 or 2 steps away from being done. Let's multiply by the conjugate, which is going to be 3 minus the square root of 3 because you always do the opposite sign of the denominator in front of the radical. So now we're going to distribute, double distribution in the numerator and the denominator. I'm going to FOIL in the top, giving me 9. Minus 3 square root of 3 minus 3 square root of 3 plus 3 all over 9 minus 3. 12 minus 6, 9 plus 3 is 12, makes negative 6 square root of 3 all over 6, leaving behind 2 minus the square root of 3. And you're finished. That is everything that you'll need to know for this assessment.